Okay, in our last lecture, we actually installed Cassandra on our virtual box and set up a table and a key space for the Movie Lens users data. So you should be sitting at a screen like this still right now at this point. So, although we went through a lot of steps to get to this point, it only took 10 minutes at the end of the day. So it may have felt like a lot, but really it wasn't that bad. So I'm still sitting here in the SQL shell utility where we set up our table. Let's exit out of that. And what we're going to do now is download a script that I wrote to actually integrate Cassandra with Spark. So to grab that, just type in wget http://media.sundog-soft.com/hadoop/Cassandra spark.py. Mind the capitalization there. And you should get that. So now we have the script that we're going to use. We also need to make sure that we tell Hadoop that we're using Spark 2.0 because this script is written using datasets, which is a Spark 2 feature. So let's say export Spark underscore major underscore version equals 2, because this current version of the Hadoop Sandbox 2.5 actually comes with Spark 1 and 2 installed, where 1 is being used by default. So let's take a look at this script before we actually run it. Take a look at what's going on here. So if you recall back to our Spark lectures, a lot of this should look familiar. It's pretty standard data frame stuff. So we start off, this is all in Python, by the way, to keep things nice and simple. So we're going to import Spark session, row, and functions, which are all things we need to deal with SQL within Spark. We wrote a function here that's going to parse out the users file as part of the Movie Lens dataset. And if you take a look at that file, it consists of pipe delimited data, where each column is the user ID, the age, the gender, which is MRF, the occupation, and the zip code or postal code. So this just returns a row object, which is what data frames expect to be composed of, with the following named columns. Users underscore ID equals an integer from the first field, an integer from the second field called age. We're going to take the string as is from the third field and call it gender, the occupation from the fourth field and call it occupation, and the zip code from the fifth field. Remember, we start counting with 0 in Python arrays, so it's a little bit confusing there sometimes, but that's basically constructing a data frame one row at a time from our source data. Let's take a look at what that data looks like. There's a u.user file. That's the one we're going to be working with. And that's what it looks like. So again, we have the user ID, user age, gender, occupation, and postal code. Now note, I actually made these names of the row match up the column names in my Cassandra database, and that's very important. They do need to match up. So now that we have that, let's walk through the rest of the code. We're going to create a Spark session object. We're going to name the application Cassandra integration. And this is important here. We need to pass a configuration parameter that says, where am I actually running Cassandra? Where do I connect to Cassandra from? So this is saying I'm just running it on my local host, 127.0.0.1. And I'll create that with that app name and with that configuration setting so it knows how to talk to Cassandra. We will then parse through that u.user file. We're going to assume that it's already been installed on my HDFS file system. We did copy that there for an earlier exercise, so make sure you have that there if you want to open up Ambari to make sure. We can log into our localhost on port 8080. Sign in as Maria_dev, There we go. It's such a challenging thing for me to type. And if we go to the files view, we can double check that that file exists. Under user, MariaDev, ML100K, u.user, okay? So if that's not there, you're going to have to upload it. Just hit the upload button and take care of that right now if you need to. But should already be there if you've been following along. So back to the code. So we've confirmed that this path does exist. That file does exist on our file system. And we're going to use our little parse input function here to actually map it to data frame rows. And then we'll create a data frame from it. So that's going to convert that RDD of rows to an actual data frame object. Once we have that data frame, things get interesting. So we can call write on that data frame. And all we need to do is under the format argument here, say org.apache.spark.sql.cassandra. And assuming that it knows where to find that package when we run the script, it will use that to actually connect that data frame to Cassandra directly. That's all you need to do. That's the only magic that's involved. We can tell it to append to that table or override it depending on what's appropriate. And then under the options, we just tell it the table name that it lives in and the key space that it lives in. So remember, we created a movie lens key space that contained a user's table in Cassandra. And this is all it takes to connect that data frame to Cassandra. We just call save, and that will actually write it out and stick in our Cassandra database all that user data. So why stop there? Let's actually read it back. So you can see that reading it back is actually just as simple. We can say spark.read, again with that same argument on format, same argument on table and key space, and this time just call load on it. And that will load up from Cassandra into a read user's data frame that we create here. And we can now just treat that like any other data frame. Pretty cool stuff. Now that we've connected this data frame to our Cassandra table, we can create a view on it and actually run SQL queries on it. So I can say, for example, select star from users where age is less than 20 and show some of the users in our database that are younger than 20 years old. Then we'll just stop the session when we're done. So let's actually run this and see if it works. Pretty cool stuff. So, I mean, the point here is that it's pretty simple once you have things set up to integrate Cassandra with Spark and just treat your Cassandra table like any other data frame. Pretty powerful thing. Let's do it. All right. Now, one little trick. You can't just pass in org.apache.datastax.sql.cassandra and expect it to just work. It has to know where to find that package. So we do need to pass that in as a parameter to our script when we run it. So let's do it this way. We'll type in spark-submit. That's the sort of wrapper script for Spark that submits the script to our cluster. And we'll say --packages datastax : spark-cassandra connector : 2.0.0-m2-s_2.11. Again, that specific package name might change in the future. This is saying that I want the version of the connector that is compatible with Spark 2.0 and Scala version 2.11. And then we can just type in the name of the script itself, Cassandra Spark.py. All right, so since we already set up the DataStax repository in our OS, it will know where to actually find that package and download it if needed, and get that in place and actually make that part of the environment for Spark before it runs. That way, when we actually say .format org.apache.spark.sql.cassandra, it will know how to get that bit of code that links together our data frame and Cassandra. Let's see if it works. All right. So it made sure that that connector package was installed, and now it's actually running it. So right now it should be busy writing those values into our users table. And it already retrieved the people under 20, so that's pretty cool. So show just shows the top 20 results, and you can see that indeed we are getting back all the users that are less than 20 years old. So a bunch of 15, 17, 18, 19-year-olds here coming back. Even an 11-year-old who has an occupation of none, apparently. Didn't put him to work yet. I guess that would be in violation of child labor laws. And most of these, unsurprisingly, are students. Not only are they under 20 and therefore most likely to be a student, this was a university research project, so a lot of these people are probably students even if they're above that age. All right, so it actually worked. That's awesome. So we actually connected a Spark data frame to a Cassandra database. Let's see if that data is actually in there. Let's go back and do a SQL shell. Just tab back up there, and let's just do like a select star from, we need to use our key space first, sorry. Use, what did we call it, movie lens? Got caught up in my excitement there. And now let's do select star from users limit 10. And you can see the first 10 people coming back there, and sure enough, our save from a data frame in Spark into Cassandra worked, and it was pretty quick too. So pretty neat stuff. Let's clean up our mess if we want to. Let's just leave it in there. We might use that later on in the course. So let's just exit out of here. And let's just remember to stop the service, though, that now that we're done with it, we'll say service Cassandra stop. And that should get things nice and clean. Cool. All right. we're done. Thus concludes our experimentation with Cassandra, and you can see that it is pretty straightforward once things are set up to integrate it with something like Spark. So again, you can use that to your advantage. You can use it for doing analytics on data that's in your Cassandra database, or for populating your Cassandra database from a Spark script. Both useful things to do. All right, cool stuff. We're done here, so let's go ahead and exit out of this prompt. That will get us back to root and back to MariaDev and finally log out. And yay, we're done for now. Congratulations. That was a little bit complicated, but it's very cool results. So that's Cassandra for you. Again, if you're in an application where you can trade off some consistency for better availability, Cassandra might be a good choice. So keep that in your tool chest. There's a lot of applications where it's really not a big deal if data doesn't get propagated within a few seconds. So often that's a very appropriate trade-off to make. So that's Cassandra. Let's talk about one more, MongoDB. We're going to explore that one up next.